So today we're going to talk about abusing web APIs through scripted Android applications a little bit. Alternatively titled All the Networks a Stage and All the APKs Merely Players. I need to put this in full screen mode so that looks a little nicer. And we can probably tell Firefox that we don't need to hear anything from them today. Okay, so thank you guys for showing up. We're going to get into some kind of deeper technical stuff. There's going to be some bytecode, some assembly, so we're going to have some fun. Hopefully you haven't had lunch yet and all your blood is in your brain instead of your belly. Because we'll get a little bit deep. So what I really hate, and what is also part of the fun of building up something to attack a new API or a new server system, is writing these kind of halfway done, jackleg, partial functionality client libraries that we all have all over when we're attacking API. Because you need to write some semblance of a client to attack a server, right? You go through and you reverse engineer and you get a basic understanding of the protocol, you understand how things work a little bit, and then you start kind of making your basic implementations of it that you can then start putting in unexpected data to attack these APIs or these servers. So all over, any attacker has partially implemented protocol stacks of God knows how many things on their laptop. I probably have several hundred just all over the place, from fuzzing things to random APIs to Ethernet controller that did a little bit of odd thing with some sort of frame. They're just all over. I wanted to look for a shortcut to that, and I think I found a good one, so we're going to talk about it a little bit. First, a little bit about me. I need to drop the font size down on that. Sorry, it's an odd system here, and I hate PowerPoint enough that I wrote my own presentation framework, so that's why we're using Firefox for this. So I'm Daniel Peck. I'm the principal research scientist at Barracuda Labs, the kind of R&D division of Barracuda Networks. I personally focus a lot on the rapid prototyping, malicious messaging kind of stuff. We look at the way malware and spam are propagated over email, social networks, IM, basically anything to do with messaging. We do a little bit of looking at compromised websites, distributing it too, but I personally tend to focus more on the direct messaging kind of aspect of things. We also do a lot of kind of larger high-level studies looking at the current state of the security industry, the current state and economics of malware, spam, things like that. So we're really kind of all over the place. Have a fun job in our research team. There's my Twitter handle and the corporate Twitter handle. Past lives, I've been kind of all over the place. I've been in the industry for, I guess, about a decade now. Done a lot of offensive work through the years, focused primarily on that. Did some control system stuff before it was cool and everybody started talking about it. So I've been in some coal plants in northern Saskatchewan looking at their network layouts. Let me tell you, that's a blast in winter. Written more snort rules than any man ever should. And I've reversed quite a few things through the years. Those are all kind of what builds to this. We're going to start off by talking about our target selection, looking at what kind of client libraries we want to look at to start attacking. We're going to build some foundations about the systems and frameworks we're working in. We're going to talk about exploring that, and then we're going to talk about leveraging it for control and really using it to attack things. First, let's get a quick overview of you guys. And I like to do things in a classroom style. So if you have any questions in the middle of it, throw a hand up, let's ask, let's learn something. Me being up here just doing the dance and bear show is great, but if we can all learn a little bit more and make sure that you understand things I'm trying to get across, all the better. So who here focuses more on breaking things day to day? Show hands. Awesome. So more defense kind of stuff? Management? Wow. One manager, maybe two. Okay. Cool. If you can get through the bytecode slides, I will be very impressed, managers. So I was sitting around waiting on a new baby to come about 2 years ago, and couldn't go out to Black Hat and DEF CON. So I was kind of sitting there bored in the living room. And at the time, we were doing a lot of work on looking at social networks and spam, because it was getting very popular then. People are doing all kinds of distribution of malware through it. And I said, okay, if I wanted to start today, and I wanted to build up a giant bot army to run on this really incredible, completely fictional social network, Facebook, how would I get started? Because it's one thing if you got started back in 2007, 2008 days when they didn't have any kind of restrictions around it. But 2011, 2012, they're really starting to lock down these services. It's getting a lot harder to make your fake clients and making things work the way you would want to if you're a bad guy. So I sat down and started trying this. This company has a great web interface that's awesome, really great API that we can use once we get a few 100,000 accounts. And we can use it with some restrictions. But creating these accounts kind of sucks. Like doing it from the web-based thing, you don't want to do it. You don't want to solve CAPTCHAs programmatically. You certainly don't want to farm it out to like a Mechanical Turk thing. Because if I'm creating 100,000 fake social network accounts, I don't want to wait that long for that many people to do it. And there's been various attempts to try to crack CAPTCHA over time, and they work well enough here and there. But for the most part, let's just try to bypass it completely. So I started thinking about mobile apps that are very important to this kind of social networky world. Mobile apps, and in general, they're very concerned about friction, especially in the kind of Silicon Valley startup model where you don't really need a business model. It's just about get as many users as you possibly can, as quick as you can, and worry about profitability later, which is we've seen the last week or two can be very profitable, even if you're not profitable. We want to create a client that mimics the mobile app to use the mobile APIs that have much less restrictions. We don't have to solve CAPTCHAs, we don't have to verify email addresses, things like that. So the assumptions we're going to work on are that Facebook uses for their app the same well-documented API that they use for third-party clients to use. They probably eat their own dog food. We're going to probably have to extract some keys, private keys, to impersonate the clients. And we're going to hope to build on top of that as much as possible. And we're going to build on existing tools as much as possible. This is a lesson I learned in an AI class in college that I ended up dropping because who the hell wants to do API all the time, or AI all the time? It's just graph traversal and it's mind-numbing. But anyway, a professor I had told us something that really stuck in my head is do the dumb thing first, because it works like 90% of the time. So use existing tools and do the dumb thing first. We're going to target Android for this, because at the time I did it, I had an Android device and I was using that as my primary device. Also, I've had at least some experience with looking at Java from the code writing side, and I hadn't done any Objective-C at all, so I didn't really want to look at iOS stuff. So I looked at Android. So we're going to talk about a few quick tools and just run through so they're in the slides for later reference on what you use if you want to do this. So intercepting the app communication, this is important because you need to understand these protocols and messages going back and forth before you can start making your own, right? So man-in-the-middle things, proxy droid's really good for that. You can run all this stuff through it. You're probably going to need to man-in-the-middle the SSL as well. If you're not, then you're probably going through way too many steps and going way too deep down the rabbit hole to attack an app. Because if they don't have SSL, that's a good key that there's probably a lot of other problems these days. So if you're not having to do that, just back it up and do something simpler. This is documented everywhere, so this is just a few quick blurbs on how to put your own certificate on the device. A few gotchas. Bouncy Castle is much less fun crypto library than you would think from the name of it. It breaks things in not so fun ways, so make sure you're using the right version of it for the app and for the version of Android. And everything is much easier if you're on the newer Android 4.0 and up devices. Like dealing with all the cert keys and stuff is a lot easier. We're also going to use Burp proxy. Anybody using Burp in their day-to-day life? Burp is awesome. If you're not using it, you should use it, and they should probably charge more for it because it's an amazing tool that lets you do a lot of things. But anyway, it lets you do invisible proxying and generate certs on demand. At the time I did the research, it wasn't quite as friendly, but now it's very friendly that it'll intercept the DNS request and make a cert based on the last DNS request as it comes in. So you don't even have to tell it the name on the cert anymore. If your client has recently looked for mobile.twacebook.com, then the next cert it generates coming back to it, that will be the CN for it. So awesome, awesome feature that's very helpful. Okay, so basic tool stuff done for now. This is the intercepted traffic we're looking at and what we're going to want to try to do. And this is very similar to what you see in a lot of HTTP-based APIs. See your basic post request, content linked, and we also see OAuth stuff here. OAuth's getting used a lot more these days, and we're going to talk about it in a few minutes, some of the details of it. But this is what we're going to basically be doing our own client of to try to get around. We see that it's very simple, passes in a password, username, OAuth signature, and it's creating these fake accounts. And from there, we can just build on them ourselves and control them through any other means that we have. Like I said, OAuth. Who's implemented OAuth in any way, shape, or form? Anybody? Wow, that's kind of surprising. I figured somebody would have by now. But anyway, OAuth is an authorization spec protocol kind of thing that allows consumers to request a key from the client and the provider, and end users can grant that token access to do things on their behalf. It sounds a lot more complicated than it is. Essentially, it's the server gives me something private, and the client says, okay, that private thing, let's do things on my behalf, and you can mesh them up, and it does a little bit of crypto to make sure it's good. So it allows users not to give their password to third-party apps. So that's a good thing, right? But it also allows providers to kind of restrict the apps that are accessing their API. Because if you have to have a certain set of keys, then people like Facebook, like Twitter, Pinterest, et cetera, can say, okay, we have this open third-party API, but if we don't approve your app, you're not allowed to use it. So it's sort of an app-level DRM we're seeing. And these keys, well, it's designed to work server to server. That's what OAuth was built for. And since most of these big platforms that are being built these days start off web-based, so even the mobile developers often work in this kind of server-centric mindset, or it's a lot of guys who did server stuff before. So OAuth came very natural, and it has been pushed down to mobile apps almost exclusively. Like it's being used there far more than servers because it goes down to one mobile app, and suddenly you have millions of users. Where server confederation talking across each other, maybe have a couple thousand for your bigger services in the world. Like I said, it's used very extensively. It was always odd for me, though, thinking that you have these apps that you're running on your desktop or on your mobile device that you don't trust enough to give passwords to, but they're running arbitrary code on your system. There was always kind of a disconnect there for me. Also, as we've seen in tons of kind of consumer hardware with DRM and such, whether it be movies or with DVDs or audiobooks, physical book or digital books, ebooks, DRM at the client level doesn't work eventually. Like it has to be decrypted on that device somewhere, right? So the private keys for accessing these systems and for saying I am a valid third-party service or I am a valid, official client are on that device or within the binary, which means that we can get the key. It's only a matter of how deep we want to go down the rabbit hole to get it. And it's not that difficult. When Twitter first went to an OAuth-based client app in it's probably 2010, Ars Technica, of all people, were the first to put up an article just showing how the key was right there, and if you looked with a hex editor, you could find it pretty easily. Ars Technica is a technical-based thing, but not exactly known for their security chops or really deep technical things. It's not that difficult. But what we're going to want to do is get onto those keys. So now we really start to have some fun. Getting down and looking into these Android applications, they're APKs. So one tool that we're going to use a lot is APK tool. It decodes the APKs. It's a nice wrapper around Smalley and back Smalley. These are tools that create the bytecode for the Android execution engine. We're going to talk about a lot. And then another tool is JD GUI that we'll talk about some as well. JD GUI produces Java-like pseudocode from the Android bytecode or from any Java bytecode. So it doesn't let you couldn't compile it and get the same functionality, but you can get kind of a high-level representation of what it does. So a little bit about Android. If you've ever been in any Android talk before at all, you've probably seen this graphic. This is all over the place. So Dalvik is the virtual machine that Android runs on. It's a subset and sort of an implementation of the JVM. They're very similar. They share a lot of the heart. It's just a little bit different how they work. So source files come in. It goes through the Java compiler. It goes to the jar tool. Jar tool is basically an archive of Java stuff. It contains all the class files, all the resources needed, et cetera, that have been compiled. That's where things go a little bit different between normal Java and Dalvik. With Dalvik, it's optimized for low memory usage, so some things happen. It deduplicates it, it makes it a lot smaller, and it changes that jar file, or the things in it. All the classes get pulled down to a DEX file, and then it's renamed to an APK instead of a jar. But they're very, very similar, right? So that's going to help us. Some more about Dalvik. It's a register-based machine, which is a little bit different than the JVM, which is a stack-based machine. It's optimized to run in low memory environments. It was all completely made to run on mobile devices with, at the time, not a whole lot of RAM. Now we're seeing, 1 to 2 gigs of RAM in mobile devices, but it seems to perform even better there. It runs DEX files, like I said. And the Dalvik instruction set we're going to go over a little bit so you have kind of a basic idea of what's happening there. It uses Smalley. Smalley is both the tool and the name of the bytecode or assembly that comes out of it. And it looks like this. So probably lost a few people right there. But this is what you see when you go through the disassembly output. It's really very simple. It looks tough, but if you've done much Java and you look at it for a little bit, it starts to all make sense. So you see it's declaring a class. The capital L is saying it's a class. So it's declaring a class CD. Another, it's doing a method constructor here in init, saying it has 2 local variables. It's putting value 0 into variable 1 and variable 0, so forth. Pretty simple to read. Invoke direct there is just a way to call methods. Return void, very simple sort of method. So deciphering it, we're going to do it a little bit deeper, but the high level overview. Parameters are stored in the P0 through PX registers. There's essentially an infinite number of registers because it's a virtual machine. Local registers are stored in V0 through VY. And there's an overlay between the last few registers and the parameter registers. So if you have 10 parameters and 15 local variables, the last 10 are overlaid on top of each other. So you'll see that some in the disassembly and have to get an idea of what's there. Registers are all 32-bit values, and all the primitives are 32-bit except for the longs and doubles. And those are stored just across 2 registers. All the primitives you have to work with, you have voids, booleans, bytes, shorts, etc. Everything that you would expect in a kind of basic language. It's a lot like C or doing really, really low-level Java. It's really not that different. Here we have commented out a little bit so you can see it more, what's going on. This is a function declaration of declaring a static method with the name A. Why is it the name A? Well, because most of the time, these Android applications go through a process called CodeGuard, which takes down the method names, class names, and all that, and changes them to, it's a lot like JavaScript minimization. So instead of, class factory, foo, method name, bar foo, create new factory, it'll be class name A and method name AA. So it reduces the size of it because a lot of the way Java works is looking up these methods as it goes through to know how to connect the dots, where to put the piping. So the name and the type, here we see there's a class of type AA that's in parameter 1. HTTP-based class is in parameter 0. Strings, and that's a return type. Starting to make sense a little bit? No, you're not going to be experts over the course of the hour, but just to give you more idea. Variable assignment, constant string that way. Again, very simple. Readable opcodes. One really cool thing about Smalley is that everything's pretty much human readable. It actually makes a very fun way to reverse engineer compared to, say, something like ARM or x86 that can really get down in the weeds and trying to remember the mnemonics of the individual opcodes. So it's a lot easier. Calling methods, like I showed before, you can invoke direct or you can invoke static. If you've done much with Java, you know the kind of eccentricities of the different stuff there. Not really important from a reversing perspective, Mostly you're concerned with the functionality you're getting out of it, not necessarily how it's called so much. But those are just some basics there. The link at the bottom here, and the slides will be put up somewhere, and I'm sure it's being recorded as well. That's the best place to get a full overview of all this stuff. So, zooming back in a little bit. Remember we were trying to get the private keys, right? So we've got all this Smalley bytecode after running through our tools, and we're looking through it. grep's a very handy tool for this, because we know a couple of things we're going to look for. It's like the HMAC SHA-1 that I talked about being an OAuth for the cryptographic signature. So that string's probably going to be somewhere, or something about crypto. So you search a little bit, you grep through, and we find this. So we know we're kind of in the money spot, because we see that HMAC SHA-1, we see some UTF-8, we see crypto, secret key spec being put in. So this is probably where those OAuth private keys live, or at least somewhere very close to it, right? But it's still kind of hard to see, especially if you haven't done any Java before, which I hadn't done any Java in basically a decade at the time that I pulled this up. So comparing the two, like I talked about JD GUI giving kind of a higher Java pseudocode-ish overview compared to the Smalley, you get a little bit better understanding because it hides some of the details about moving things between the registers. And you can see more of what's going on here. Go back and forth for a second, show again, the Smalley, and you can kind of get an idea of what's going on there with invoke direct in the key spec, and compare that to key spec and the parameters being passed in. So awesome. So basically looking at this, we've got a good idea of what we need. We might still be a little confused. Maybe we don't know much about the crypto APIs, right? So one really cool thing for reversers to do these days is if you have a problem, chances are the people who engineer the app you're reading or trying to manipulate probably use Stack Overflow. So, see any similarities here? So we know this is the direct Java code that they basically copied and pasted into the app. And it's probably been copied and pasted into thousands of other apps, because there's only so many different ways to sign a message with HMAC SHA-1. So once I found this, I was like, cool, I understand exactly what I need to do. I basically need to grab whatever that the string variable key is from the debugger, and then I know exactly what I need. I've got the private keys. I can start working and building up my client more, right? So do the dumb thing first. We turn to the tool of the favorite tool of every freshman computer scientist in the country, and probably the world, is printf debugging. Essentially, one of the cool things about Smalley is that you can manipulate the app, put in new instructions in it, and then rebuild it, and it works completely. You don't have to worry about offsets or anything like that. So we can just throw in these couple of strings at the top, putting in a constant string into the variable 2 of secret key and v0, and then we call this Android log function with that key that's passed in. So, and then looking at the log after rebuilding it, and we see, boom, we got our secret key. Awesome. So we're doing the happy dance now. We're feeling good, feeling really good. So we've learned that we can kind of get through and understand these APKs at least well enough to grab things out of it, to manipulate, to understand the keys, and that's good. But we still haven't really got to the point where we can use their code at all, right? We still have to write our own client, basically from the ground up, to get to the point that we can send these messages that are signed with these keys. And that gets a little tough when you come across some custom crypto code, because I can duplicate a lot of functionality from a client, just reading the disassembly. And if you're into it, you can do it as well. But when you come across like a custom hashing function or crypto code, and you're trying to get back to sort of a high level what it means and what it actually does from a low level like Smalley, it's a nightmare. Like, I can do a lot of things, but it ain't one of them. So in this particular app, found a routine that's being called, and it's about 30 pages of this nightmare of adding things, shifting bits back and forth. That's not fun at all. Even looking at it in the JD GUI kind of way, doesn't really give you much better. If anybody can tell me, I'm going to reduce the font size a little bit here so you can see it more. Yeah, that might be too much. Anybody got idea off the top of their head what this function does? Pretty high level Java. It's pretty simple functionality you probably used 1,000 times a day and never even think of. So this is a base 64 encoder. But really tough to see that from looking at the disassembly. I could reduplicate it. I could use any of the libraries built into the languages I choose to write base 64. But then you have issues of base 64 implementations that are a little different because there's multiple implementations of base 64. Might not have known that. Which one does this one use? Well, it could be a lot of trial and error. And if they've written this customly, which it looks like it did, or it inlined another library, you know, what idiosyncrasies it has, I'm going to have to match up in my client. That sucks. I don't want to do it. That's going to take a lot of time. It's going to be very error prone, and I might not ever get to where I want to go. So I sat down and I thought about things for a little while, because I didn't really want to do that. Felt like I was more or less at a dead end. And then I started thinking more about how Android works on JVM-based platform. A lot of other cool things work on the JVM-based platform. And how APKs are basically glorified jar files. JVM-based languages have really become very popular in the last few years. Jython was a huge hit. It's kind of waning off. JRuby is, what I see anyway, is the future of Ruby that I use as my go-to language a lot of times. Clojure, Scala. Scala is huge. It's basically what Twitter has moved a lot of its infrastructure over to. So if that's any sort of a positive for it, if you can run something like Twitter on it, there's probably a lot of cool features on it, a lot of power. Java is turning out more and more to be like the worst case implementation of what you would use the JVM for, where these other languages give you all the power of the JVM that's had some of the smartest computer scientists in the world working on it for the last 20 years, but in much friendlier ways and much less error-prone ways than Java. You can also get the huge number of libraries available with it and do some cool stuff with that. So like I said, my language of choice is Ruby, so JRuby is what I turn to. So like I said, decks are just another kind of jar. A tool that you'll find pretty much everywhere in the Android kind of reversing world is the dex to jar. So it takes a dex file that you pulled out of the APK and it converts it to a jar file. We can then, through the magic of the JVM and the good people who spent all the time writing JRuby, we can load it up and just treat it as a client library. So we've shortcutted a huge number of steps to get to this point, to be able to just say, import this class name, but you have to do this little trick because Ruby hates lowercase class names at the start. So you have to say, what the class name is going to really be and just give it any string there. But it's pulling in the CC class, which was obfuscated before. And then you can call that A function, get the signature back. So this is that base 64 function I said. So it just pulls it in, you get the signature right there. You can iterate up and bypass a whole lot of things and make your life a lot easier when you're doing this. You start finding things in the code like what essentially amounts to a user class, an API factory class, to just create new users. So you can use this library's whole functionality, or this client application's whole functionality, just like it were a jar file in and of itself. Like it was a DLL, shared object, whatever your parlance for the environment you work in. Incredibly helpful. You don't have to worry about your oddly put together implementations that's going to have its own bugs. You can use theirs. You can also just bypass functionality at will. There's crypto checks, but you need to call this other function past it, just call it yourself. You need to override a little bit of their functions, you can override it right in place. So we're doing good. This is really probably a terrible example here, but this is how you can go through and figure out all the methods that are in it. Like I said, the slides will be up somewhere, so don't worry about getting a great overview, but you can just grab the jar file, and then for each entry, you get the name of the classes, and you can import each one, and then get the instance methods from it. This is a lot of the beauty of a language like JRuby that lets kind of runtime duck typing. So you can just grab the class, instantiate it, and then see what kind of methods it has in it. It'll tell you that at runtime. So you can, with this, and a little bit of putting into your graphing library of choice, see a full graph of everything that this library offers, and all the methods, the inputs, things such as that. So, fun times. They said it leads to a very dynamic and even fun style of reversing that basically amounts to this as the steps. You acquire the APA, find your interesting functions, load the classes, and then just start calling them, like we do with any sort of reversing. But you don't have to do it as much statically. You can do a lot of dynamic testing and run the function with these inputs. Did I get the outputs I expected? What if I throw these other things into it? Back and forth. A few known issues on that is native code methods kind of blow up right now. I think there's workarounds, but there's a few methods here and there that are implemented as native code instead of the Java code. Like a lot of games that do a lot of high-end graphical stuff on Android devices will use native code to do that, so they'll call out to that. Obviously, this doesn't work at the moment because sometimes the native code's not there, but the JVM doesn't really know how to load that up in a dynamic way. It just knows how to call it as needed. So there's some issues there that I think can be worked around, but haven't got to it yet, and they're largely inconsequential to the kind of things you're going to be doing anyway, because you're not really looking to run Angry Birds from a JVM, JRuby session when you're attacking a server. You're just looking to call the methods that are going back to the server. But you're going to find that here and there. I'm sure that there are some incompatibilities between Dalvik and the JVM. That said, I haven't found any, but I have to believe that they're there somewhere, but in my testing and the apps that I've used with this approach so far, have not come across any issues with that. So getting back to what we wanted to do to begin with, in the second part of this presentation, is all the APKs but players. Is what are we going to turn this into? Well, we wanted to make a lot of social bots. And what I found when we did this is a lot of these fake social accounts are really, really terrible. And I don't really understand why the bad guys don't kind of up their art a bit. So I wanted to see if I could, because that's the kind of thing I do. We found a couple really, really good, the bad people doing bad things. But the fake kind of profiles they create on Facebook, some of them are really well crafted to the point that they'll like wish their followers happy birthday. They'll share, funny videos, occasionally put out spam and malware. But it's a very difficult problem for social networks and for people engaged on social networks to determine what's a malicious account, strictly there for maliciousness, and what's an account that occasionally gets compromised. And this is a problem that the guys running Facebook and Twitter and such have as well, because there's not a lot of good ways to determine that. You have this very kind of flat, 2D environment where you don't understand, where you can't get a full view of someone. It's just the post that they've made and the people they follow. There's not a lot of dimensions in that. So I wanted to make some fake social bots, and I turned to my past of being a teenager playing a lot of video games, and I thought, well, how can I make really good NPC characters? Well, you need good seeds to start off with. So there was a good dump of data from Facebook in 2010 by people at Skull Security, who I've never heard of before or since then. But anyway, the torrents out there had, at the time, a very large portion of Facebook's users, 100 million accounts and account details, the unique ID, gender, username, etc. We can also look at U.S. Census data that associates last names with likelihood of ethnicity. Ethnicity can be mapped with weights to regions, and regions can be mapped to area codes, zip codes, etc. Essentially, we stereotype, which is not good to do in person, as we all know, but for creating, basically kind of flat bot kind of people on the web, it works very well. We're also going to turn to Facebook Together public profile images, which are very easy to find with the previously said data. And you can give your bots realistic interests very easily. For example, Twitter suggests categories that you might be interested in when you create an account, whether it's movies, books, TV, cooking, gardening, etc. So you just pick a couple of those, and then your bots now have interest. A little bit of Bayesian filtering, and you can determine what posts to the public stream fall into each of those categories, and then it can randomly grab one every now and then and put it out, and it looks just like any other member of the community. Occasionally throw a little bit of spam, a little bit of malware in there. Cost of doing business, right? Most of the social networks are going to deal with that as needed. So you end up building social bots like this that look pretty credible, I think. Stacy Jackson, she's from Evergreen, Colorado. Her username is SassyStacy303, which is the area code around Denver, where Evergreen's kind of a suburb of. She likes movies, books. She posts moderately, a couple times a day, and she friends easily. These services, recommend people who you should follow based on the region you're in, your interests, etc. So she follows about 15% of the people who are recommended by these services that she should follow. So why would you want to do that? Well, clearly the spam malware angle works pretty well. But an interesting thing we found as we were doing this research is the monetization of selling followers works a lot better than doing the spam or malware right now. You can sell 1,000 followers for about 11 bucks. And the average person who purchases these fake followers, they get around 50K of them. Of course, you don't get 500 for that. You get a bulk discount with these services. But anyway, it makes a lot of money in these kind of back channels, back market, social follower selling things. At any given time, there's about 50 vendors going on. You'll see them on Fiverr, on eBay, etc. People want to do it for various reasons. Like a lot of musicians will do it to look better, to look like something that venue owners might want to bring them in for, because if they've got 70,000 followers, you think, hey, I'm going to fill up the bar that night, I'm going to make a lot of money. Or they want record label people to say, he's got a lot of people, maybe we should sign him to a short-term contract. You also see a lot of people just some people involved in the InfoSec community have done this as well, where they've bought a lot of followers to appear to be more insightful, to have crossed the bridge from InfoSec to kind of general technologiness, to pontificate about on Twitter or whatever other networks. It's very popular to do. It happens more and more, and is kind of a big part of that thriving underground economy. So that concludes it. We've got a few minutes for questions. It was kind of a high-level, all-over-the-place overview of kind of a story of getting to it. Thank y'all very much for attending. There's contact info, all that stuff, and we'll do a couple questions. In the back? You trailed off there at the end. Could you be a little bit louder for like that last 2 sentences? So the question is, when you're decompiling, you might not be able to get the more Java pseudocode view. And why would that happen? How do you get around it? Correct? Okay, so if you can't get it, it's probably because the application is doing some odd things with maybe CodeGuard or some of the way they've structured it that the JD GUI application just doesn't get. In which case you are at a crossroads there of you can dig really deep and get into it and try to understand why it doesn't work. Or you can just go straight down to the Smalley level that you're always going to get, because that's bytecode. You're going to always get that, which it makes it harder to get, but you also are never misled. The JD GUI code isn't always accurate. It just gives you kind of an idea of what's going on at a high level, where the Smalley gives you exactly what's going on. What happens in this register, what happens in this variable, and how they interact. So my personal, and I've been reversing it a long time, so it might not work for everybody until you become very comfortable with it, is just go down to the lowest level possible and only iterate up when you need to. Because soon enough you're going to start seeing patterns and really understand what's going on in that bytecode level. Yes? Yes. Okay, so the question is, how was the key we found used? So the key, that's the OAuth key, and essentially what it does is it creates that HTTP method that we saw at the front with all the OAuth signature and the password and the username that it wants to create, and it signs that message and creates a HMAC SHA-1 signature. So it uses that private key as the seed, and then the server can say, okay, I know this was signed by my private key that I put out in my clients, so I'm going to accept it. Well, we're creating user accounts in this particular example. So it does check it to make sure that you're not, creating a new one with the same thing, but it's more to validate that that's an official request from an official client. Yes, yes. This was all to automate and get around the building your own client library to use their client library, or to use their client as a client library and then start having fun. Any other questions? Yes. I have very few followers, only about 600 or so. I have not personally used any of mine for malicious purposes. However, I will say that I created a little over 10,000 and then got kind of bored because this was all done over the course of like a day, day and a half. And I'm not going to do anything malicious with them. So it was just kind of was what it was. More than 9,000 of them still exist and haven't been shut down. So they interact with the community very well. Some of them have a lot of followers, some have few, some follow each other. They're, for all intents and purposes, just as real as anyone else on this social network, Facebook. Anybody else? All right, thank you all very much for your time. Appreciate it.